the Smartboard lesson. Could someone maybe write in the chat that just says, yeah, I see intro to solving equations. That's what we want to see. Okay. So you would have done equations in grade 7 and been introduced to them. In grade 8, you would have done maybe multi-step equations. So you should be pretty used to this. All right. So the introduction to solving equations. So when we solve equations, we want to substitute in an algebraic expression. That means to replace one variable. So if you have an x variable, you put in a number, and that could be any number that you want or you're asked to do. Often we place a number in brackets, especially if it is a negative, because you want to contain that bracket. If a variable, if the variable we are substituting is a coefficient, then that coefficient will also be multiplied by what's inside that bracket. Then when we use the order of operations, so you may have done BEDMAS before, and so I've been sort of over the years deciding to think of something called GEMMA, and so BEDMAS, if we remember, was brackets, exponents, division, multiplication, addition, subtraction. GEMMA is a little different. So GEMMA is grouping. And grouping would be the B and there's other types of groupings. So hopefully we'll see some of those. But groupings could be things that are in brackets, things that appear on top of a fraction line. Exponents are pretty clear, but exponents are, exponents like this, but exponents also include the family of radicals, meaning they are also, okay, so Luca, you don't see the lesson, do you now, maybe, Luca? Maybe Luca could respond. Okay, so exponents also include any square rooting also. Multiplication and dividing, that's good, but that could also become, when there's brackets that we're multiplying, brackets that we're dividing, and then add and subtract. And you try and go in that order. So we use the order of operations, GEMMA. All right, given the expression, so right now we're just talking about expressions. Remember, expressions don't have a left and a right side. We're going to evaluate. So we're going to substitute. So Luca, you still don't see it, eh? Kelly, no, or you have. Oh, that's a good point, Luca. If you can find my screen, and then when you hover over it, you'll see like a pin, and if you press on that pin, then it will freeze my screen and show just what I'm presenting. Awesome. Okay, Luca's got it. Yes, I really like, anytime you guys have a question, right? That's what the chat is there for, because a lot of you have muted your mics. All right. So we're going to create brackets for the 2 to go into. So if we have 3x, well, the x is replaced by a bracket, and this is a little bit tricky, but the x is squared. So we're really only replacing the x. So the squared still exists there, and the 4 and another bracket. We want to have our equal signs along the sides, making it a nice solution. So what are we going to put in to that bracket? Well, we're going to put the 2 in. All right, now that we've done that substitution, then we have to follow our GEMMA. So are there any groups? Well, this is sort of a group, and this is its own group. But there's also, these are also multiplication and some exponents. So there's nothing we can do, like there's nothing inside this bracket that we could do on its own. So we move along to exponents. Well, there are an exponent we have to do. So we can do this one first. So 3 times 2 times 2 is 4. And then really we haven't touched anything else in this next step. Okay, so we've done grouping, we've done exponents. Now we do multiplication and division. So we have 2 things we could do at the same time. separately. So 3 times 4 is 12, and negative 4 times 2 is negative 8. And then so we're done all the multiplication dividing. Now we can do the add or subtract. And we have 4. Okay, so that would be, so if x was 2, then our solution would be 4, whatever that expression means. Right? It could be, that could be tiling your kitchen floor, and that's some sort of expression that decides how many tiles you would need or how many square meters it would be. We don't really know what that would represent. Okay, so we go to the next page. An equation, an expression doesn't have an equal sign with left and right. Equations have a left side equals a right side. So an equation is a statement then that's showing that two mathematical expressions are equal. So in other words, the left side and a right side. There's a left side and a right side. So we can say there's a left side, right side. All right. In the equation, for the equation to be true, okay, an equation must have the equal sign in it. And the solution to an equation is the value for the variable that makes the equation true. Okay, so whatever that number is, we have to solve for it. Or sometimes you can guess, but I try to teach you guys not to guess too much. So that is when you substitute the variable with the solution, the expression on the left side evaluates to the same number as the expression on the right side. We can verify the solution from a formal check, which involves separating the equation into two expressions. We're going to use a T-chart. So anytime I say use a T-chart, this is what we're going to mean. So we're going to say left side and right side, put a T. Okay, so a formal check, we're going to see what happens when we put 3 into both of these and see if the left side is going to equal the right side. So 3x gets replaced by a bracket, negative 2 bracket 13. What are we going to put in those brackets? Well, the 3, of course. All right, so let's everyone make sure. Notice when I'm using a T-chart, I don't need any equal signs here. I don't need to write that because it's sort of split it up. It's like a teeter-totter. The left side must equal the right side. All right, so we have to follow the rules of GEMMA or BEDMAS and say we do multiplications before we do any addition or subtraction. Okay, negative 6. All right, double check. We didn't make any mistakes. Very good. And then we have 9 minus 2 is 7, and negative 6 plus 13 is also 7. So that's great. We can say left side equals right side. So we were asked to verify. Okay, so therefore x3 is the solution because it was equal on both sides. If we had gotten different numbers on, then we'd say, sorry, x3 is not the solution. Any questions? If you have a question, you can put it down the chat, or you can unmute your mic if you'd like. I'll give you a few seconds to decide if you have a question. Looks like we're doing well, I hope. Okay. So sometimes we have to build our own equations, and that can be tough because language is tricky enough as well. So anyways, we'll try and take a crack at it here. Okay, so often we will need to create our own equation from a word statement. So to do this, you must be able to translate some of the terms. So I like to have the chat showing on the side. All right, so what would you say sum? Well, sum has to do with a plus sign. That might, this is going to be translating into an equation. A difference, we're always looking for the negative. Product is a multiplication. One that we just don't use it in normal language is quotient, but a quotient is division. If we're going to look at something less than, then we are going to use our negative. More than, we use our positive. If something is times something, we are multiplying it. And is an equal sign. So what we want to do is take the language here, the word statement, and dissect it to come up with an expression, okay, or an equation. So as we read through, we say the product. So again, product was multiplication of 7 and a number. So anytime you get a number, oh, you know what? Let's use n then, because use x for multiplication. So multiplication. Let's use n for a number. We don't know what that number is, and then is an equal sign. So the product of 7 and n, these two together, is going to be 56. So 7 times n, because remember when a coefficient and a variable are together, it's multiplication. And we have our is 56. Now this did not ask us to solve it yet, so we don't have to do that. We don't have to go any further than that. But this is now an equation that we just made. All right, keep going. The sum, now sum means plus, of a number and 8. So a number plus 8 is 17. So n plus 8 equals 17. All right, this is your turn now. I want you to take this next one and try it out before I give you the answer. And see if you want to type it, if someone wants to type it in the chat, what they think it's going to be. And go ahead and try all three of you if you're working ahead. If you want to. We can still make this interactive. So I don't see anyone chatting. Everyone too shy. It's okay to be wrong too, but I think you're going to be right probably. Give yourself a chance. All right, so we got Rachel trying it out. 5 plus 2, 2n we can say is 11. So let's see what happens here. So 5 more than 2 times a number. So 2 times a number is 2n. 5 more than that is a plus 5, right? It's like we're saying plus 5 more than this is 10. So I have a good feeling about this, Rachel. I think, whether you write it kind of this way or the way you wrote it, or rearrange it, all three versions are fine, right? So the way we kind of read it was sort of like 5 plus 2n equals 10. There's no real reason why we would want like an x, a multiplication symbol in there. So that's one thing you could just change. Because it automatically means when we have the 2 right beside the n, it just means multiplication anyways. All right, good. There's tends to be this way that we kind of write the term with the variable first, and then the constant or the non-variable second. It's just sort of like a best practice, but there's no true rule about that. All right, let's try the next one. So who can get this answer? you all have a notepad of paper right beside your computers with a pencil, with an eraser, and you're jotting this down as we go, I hope. Or you have your note package, which would be fantastic. All right, so Jonah, I have this other little screen. I don't know if you guys see it, but it's from the Screencastify. I have to put it in a corner, but there's no good corner. All my corners are so busy. All right, so 7 minus 5n equals -3. That's what we're guessing, right, Jonah? So good prediction. So let's try this out. So 7 less than, so 7 less than, so it's going to be a -7, -7 less than 5 times the number. So 5 times the number is 5n is -3. I think you're right on here, bud. So 5n minus 7 equals -3. Very good. So whether you use n or t or x, the variable doesn't matter. Sometimes I find with a number, n works well, especially when we're talking about multiplication symbols. It can really confuse us, so x isn't always the best, but then we tend to use x in most of the course. All right, last one. So it's a bit of a race. Who's going to, maybe Rachel and Jonah, just ease back and let someone else, we need a third person to come up with an answer here. So, we're looking for Daniel or Ella or Luca might have this one. I know there's like 12 of you out there, so let's see who, Olivia might get it. Arwin, see you there. Lola, I think I saw Lola. So, Luca's got it. Okay, so so 2 times the sum of a number and 3. You are so close. You're so close. So one thing we have to do first, because it's 2 times this combination. So this is a little different. So I'm really glad you tried it because it's a bit of a different idea. Let's get a different color here. We need something that. All right. So 2 times whatever these things are. So if you said that these were a bracket, then we can have 2 times whatever's happening inside the bracket. So you're super close because you said 2n plus 3 equals 14. The only thing I would change about that, Luca, is I would bracket that this has to happen first. So the 2 times the sum of these two numbers has to happen first. Then we're going to multiply it by 2. Now let's just erase this so we don't think there's a negative on there. Okay, so that's a bit tricky. So that, Luca, you changed it on the chat. So everyone realize that, like the 2 times the sum. So this is saying then we have to do it the sum of these two things first before we multiply. So you can see how the wording can get quite tricky. So you want to be careful with that. All right. So we just did Gemma, and Gemma means we have to follow a certain order to solve things. And then sometimes we need to do the reverse. So like solving an equation or making an equation is like raveling a ball. And to solve that equation, we have to unravel the ball. Or we do a puzzle, and then we have to undo the puzzle. So in inverse operations are the reverse of Gemma. So inverse operations, and every math operation has an inverse. That is the operation that reverses the effect of the other operation. So we can undo what we just did. Addition, the inverse is subtraction. Subtraction, the inverse is addition. Multiplication has the inverse of division. Division is the inverse of multiplication. Squaring, squaring is the inverse of taking the square root. Taking the square root is inverse of squaring. So kind of get the point here. So determine the inverse operation for each math statement. All right. So what is the inverse of 4 times 9 is 45. Well, the inverse, if we did division, if we did multiplication here, we want to do division. So you kind of reverse it. You say 45 divided by, doesn't really matter which number, 9 is 5. So it means rearranging things to sort of look at what the, how to kind of reverse what you just did. Sorry. I'm curious, when I do that, does it show my screen, or are you guys still looking at do you still see the notebook file even when I click off of it for a second? I'd be curious to see what you guys see when I do that. Okay, well, we are saying what is happening to the first one. So the 5 is being multiplied by the 9, so we do use the 9 in the reverse operation. So the 14 subtract, so subtract is the inverse operation, and 8 gives us the 6. So we sort of want to like figure out the inverse operation of what's happening to the 6. How do we get back to 6? How do we get back to the 5? Right? So what about this? How do we get 16? How do we get 16 back to 4? Well, we square root the 16 and it gives us back to 4. So that's sort of the thinking there. I think it makes more sense when we get into actual questions. All right. When we solve equations, so really we're working towards solving equations, so solving a missing variable in an equation. We need to determine what math operations have happened to our unknown variable so that we can reverse those. And we want to think of them as in the GEMMA. What operations have happened to the x in 3x minus 5? List them in order. Okay. So the first thing that has happened to the x, what's the first thing happening to the x? So I always think of this as like, well, some of you might be Shrek fans, and in Shrek, he says ogres are like onions, and onions have layers and layers and layers. Ogres have layers. Anyways, I always think of that for some reason. But math equations have layers. So math equations have the first layer, the second layer, and the third layer. What we want to go the closest layer to the outer layer. So what's the first thing happening to it? It's being squared. The x is squared. Okay? So it's being squared. What's the next thing happening to the x? Well, it's, again, a coefficient beside a variable. So it's being times by 3. Good. Okay, and then what's the next layer? It's being subtract by 5. Good. So sometimes, not to get confused with a T-chart, but I kind of say like these are our operations. Okay, and what is the inverse? And that's what our question asks, isn't it? You can read it. What are the inverse operations? So when we do the inverse, we go in the opposite direction. Oh my, different order. So what's the first thing we're going to do to undo this? Remember, we're going to wrap up this equation. Well, how do we unravel? How do we ravel an equation? How are we going to unravel it? So first thing is we're going to add 5. If we were to solve for x, we would want to add 5. Second, we want to divide by 3. And then third, we want to square root. Square root the x. And so that's what we would do. Now this isn't a true equation because it's not equal to anything. So there's nothing really to do. Today was just about getting us familiar with what equations are, what they look like, how to consider the order of operations, and then finally, what are the inverse operations that would undo those first operations? And by doing that, we can eventually solve. So today was just an intro to that. So at this point, I'll pause it, or I'll stop my video.